All right. There we are. It has been so long. Like, so long. Last time I worked on Lux, that was like ages ago. I mean, I still work on Lux, but anyway, I'm gonna just like make another scene. Whoops. Just so y'all can also see like the game, or actually, you know what, I might just resume it. Like I might just zoom in. Yeah, there we go. I'll just do this. It's a bit impractical, but I didn't think of that before. That's fine. Alright. So anyway, right? Prism. That is a thing now. Prism is a thing now. So I'll just do it this way. We'll have to live with it. Yeah, I'm wondering how the performance on the live stream will be. I'll actually check that on my phone, because like I'm watching the stream on my phone, which is kind of funny. I'll just check how the performance is for a second, and then we can get started and so on. But I think it should be okay. Otherwise I'll tone the settings down a little bit. But it looks fine to me. Yeah, that's cool. Because I'm not running at like a great FPS count right now, I'll be honest. It's not amazing. But it's it seems alright on the stream, so that's good. Alright. So anyway. Yeah, Prism. Today I mean I didn't like make a whole plan for what I'm gonna do. I'm just here working on it, and I can answer some questions and so on if anybody has any questions. But yeah, mostly just to work on this and not procrastinate, because I found in the other stream actually that for some reason it really helped to like stream to get stuff done, and so I'm gonna try that out again today. Because I've been procrastinating on improving my temporal filter for what feels like ages. And so that's what we're gonna do today, mainly. And then we will figure out the rest later. And that's Nans, I assume, or maybe it's just night. Probably just night. Okay. So yeah, I might just get into like a test world or something to do this actually. Because this is a lot of geometry to deal with. This can be the stress test, if you will. But for implementing, that might be a little too overkill. So I'm gonna just, yeah, I have this world, which is cool. We'll build a little thing to test out things and stuff. Yeah, I need to fix the hand still, if you're noticing that. That looks that way for a reason. It's not necessarily wrong, it's just I didn't fix it. Alright, so we'll just like make a little area here. Let's make a little, I don't know, what is this? I think this should be approximately a rectangle. Ah, I was way off. Just put the master volume down here. And you can see already that, you know, it doesn't update, which is not necessarily due to the temporal filter. If you were trying to counteract that just with the temporal filter, then you would have to crank up the weights or like the sensitivity of the of the weights way up, and I don't want to do that because that would come with a bunch of artifacts and noise and reduction and like variance that we could have otherwise gotten. But yeah, so I'm gonna just make a wall here, and then I'm gonna make what can we use for this? An oak fence, sure. And then that way we can kind of check how well it rejects samples. For the moment, that should be good enough to, like, as an indicator if it's kind of working. Because there was a paper I was gonna look at to, yeah, test out the entire temporal filtering thing. We'll just size that back down. So I'm gonna just search up the paper first, and then I'm just gonna add, like, that's wrong. I'm not the greatest with OBS, I'm gonna be honest. That will be my browser. Okay. Browser window. There we go. That is fine. I'll just open like this in another tab so you guys get to see my analytics for a while now, I think. Or no, not even. You're just getting the the stream twice. That's awesome. We'll just have to switch back, I believe. Yep. Okay, cool. So anyway, there we go. Yeah, so the paper, right? So there was something that the SVGF paper linked to, I believe. And that's mostly what I want to go by. So let's see here. Reconstruction pipeline, temporal filtering, there we go. We minimize these artifacts and increase the effective sample count by instead adopting a geometry-based temporal filter inspired by ideas from Rehab and Yang. I probably butchered those names, that's fine. These consistency tests use empirical similarity metrics similar to the fragment match heuristics. I don't care about that too much. I mean, this is essentially what we're doing. If you look at, I'm just gonna hide this window quickly. I will, hello? Where's my files? I don't need those necessarily. It's in deferred 1. So anyway, deferred 1. Right. This is all still a bit messy, so I need to apologize to any developers out there, but this is just the way my deferred program looks at the moment. Because this all is basically the temporal filter, and I just didn't take care of it before. So that's that. But yeah, so mix is basically just that. Mix is basically just what they are saying there. Alpha would be like the third parameter, and then these would be the first, like the first and second parameter of the mix function. And yeah, the rest of the paper is good too, but it's too early to get into that yet. So I'm gonna check out the papers that are linked here. I'm not gonna do a whole lot of reading. I'm just gonna take a quick stab at them and see if they have any ideas that I haven't had before. So that's... Do they have reference links? I mean, even if they did, it's kind of a pain to deal with because they're so crammed up. Are they at least like sorted by last name? Oh, there. Accelerating real-time shading with reverse projection caching. And we can take a look at it. I'm not sure that this is going to be helpful, but we can take a look at it. That's wrong. Here. Yang from 2009, so this is gonna be like here. And more inside super sampling. Oh yeah. Yeah, this is more like it. I think this is also kind of like TAA basically. I think this is, yeah, this was like essentially a TAA paper rather than a temporal accumulation paper, but it's, I mean, both algorithms basically use the same thing, so I am not surprised that that's getting referenced there. Alright. So... do they have any specific geometric weight factors here? Because that's ultimately what I care about. I don't think so, right? Let's see. I mean, this... it's a good paper. It's just probably not what we want. Doesn't seem like it to me. Yeah, let's go. I've already thought that this is probably gonna be rather what we want. Cool. Okay, so stationary viewport and static scene. This is essentially what just accumulation would be. So this seems to be like the mix factor, essentially, like the last part of our mix function. Yeah, uniform weights. That would make sense if like the scene wasn't changing and we were not moving. This causes the estimates to converge to perfect anti-aliasing, with variance decreasing as divided by t. Okay, so it's the initial variance, or just the function we're sampling, which we don't know the variance of a single sample of, but that doesn't matter. Divided by t. Cool. Moving viewport and dynamic scene. The presence of relative scene motion significantly complicates the task of amortizing over multiple frames. Duh. Okay, so that's what we want. I think this is like the part ultimately. We just want to know how specifically we want to modify the the weight. Like, what weights do we want to use for that? Let's see if they talk about that at all. When a surface point becomes visible, we initialize this. In subsequent updates, we apply the rules. And that, as discussed later on, the presence of scene motion requires us to limit this indefinite accumulation of uniformly weighted samples, even for pixels that remain visible over many frames. To do so, sections 5.2 and 6.2 describe lower bounds on the value of right 6. Okay. Sure. The way I'm doing this currently is kind of messy, so this is like a lot more understandable, probably a lot more sophisticated as well. Okay. That this reduces to 7 when this is not overridden, so in practice we always use 8. Okay. Okay, so this is the general equation. So S is the... what would that be? The current frame, and this is the last frame? I think that's what it is. Combining a new jitter sample, right? That's okay, so that's the current one, and this is the last frame essentially. So this is our mix factor. And N, the new samples are accumulated, leading to new update rule. I mean, what does NT really represent? Is that like the total like amount of effective samples that have been accumulated? I think so, right? Oh yeah, right. No, okay, so it's just the... Yeah, I think that's what it is. I believe, question mark. So anyway, let's do that first. Yeah, let's make sure we have the first part of this implemented correctly, which is like which is confusion. What am I doing? My PC doesn't like me right now. Something's wrong. Hello? I think... Oh, is it Minecraft? It might have been. Something went terribly wrong there. Okay. I might just tone the settings down actually. It didn't seem to lag, but maybe it's too taxing. Anyway, right, so we want to do this first, and like the reinitialization, this basically. So yeah, I'm just gonna go into my dev settings very quickly just to check and make sure that the settings are not too like pushed too far. And I'm gonna try this again. So now you will see that we get some funky thing going on here in the corners. That's like because of precision issues, and I believe it's a common issue. I've talked to developers about it, other developers, and they said it's normal and it usually goes away when you do the denoiser at full resolution, which I hope it will, because this is very annoying. But yeah, so we go back to the third one. So what am I doing right now? Okay, so temp A. Okay, so I'm waiting like that one that they have there by the weight, which I apparently shouldn't be doing. I should rather, and I guess that's what they're saying, find a metric for, is this the same point in space or not? Right? Essentially. So I'm gonna just go ahead and try to do that. So, we can say like if the weight is low enough, right, that that it's essentially new pixels. So what we would do is say color text 15, right, would be, I don't know, like W is below 0.01, which would be like 1% of the previous signal, which is very low. And if we were to say that's our metric, I believe that hypothetically, nothing happening. Okay, maybe our weight is not aggressive enough then. It probably just is not aggressive enough. Let's see how far we need to push this, because I can't believe that it's gonna be that high. Wait. Let's see here. W? Let's see. Why is W so, like... Do we need to convert this to float first? I don't think so, right? No. I mean, the max that this can be is 1. So, you know, I'm surprised that this does not actually give me what I thought it would. That is very odd. You also don't need that many chunks just to do this. So W, like, let's just make a true statement to see if that... Oh, okay. No, I think I can see what the issue is here. I think. I'm not sure, but I think. So let's go to deferred 10, I think it was. GI. That is 15, okay. Albedo times GI, that should be fine. Whoops, I don't want to do that. Deferred 1. Okay, so... I don't think there's anything else that writes to this buffer, so I'm kinda surprised. If we just, like, actually make this one. Maybe it's not bright enough, because I think we're scaling it down a lot, so let's, like, be stupid and do this for a second. Oh, okay, there we go. Now this looks a lot more like it. So anyway. Yeah, that's kinda the pain of shader development. And like, I mean, mainly just like physically based shader development. All the other kinds are kind of more forgiving, I would say. At least in my experience. Okay, now why? That's still awfully... Okay, I think I'm just pushing this too far, probably. But maybe I'm also just not... Yeah, I guess if like if the movement is not strong enough, it might just not register that as like an occlusion. That might be the case, actually. I did not think of that. But what if we just go by depth? I think that might be even better as a metric for occlusion. That certainly looks a lot more like it. Right? That's our metric for disocclusion. That might be working. Or maybe they say something in the paper about that. But I don't think so. Also, I'm just noticing every time I switch windows, something lags my PC a little bit. It's fine. It's just kind of annoying in the long run, I guess. Okay, I think we're back. That was weird. Okay, so I think how I'm gonna do this from now on is I'll just like exit out of like the game world and then open other windows, because for some reason this is not good for my PC and it doesn't like it, which is fine. But I don't know. I'll find a solution to this eventually. But yeah, so how do they model the way a point gets visible for the first time? Because I have no idea how to do that reliably. So algorithm, okay, so evaluate sample, update once, compute the output pixel color, update the new pixel effective number of samples. Okay. Evaluate a new sample. Alright. Nearest center of the quadrant being updated. Okay. Okay, so it seems that they are doing some sort of tint filter, which to me, that's just like a linear fall off of a blur kernel. Yeah, I think it is actually. Minimize the amount of blur. Okay. I mean, I'm not sure if that's needed. Okay, so they're jittering with like in a Gaussian manner. That's interesting. I never thought of that. I've always used thought to use like pseudo-random low discrepancy sequences instead. Always seemed to be more efficient to me, at least. All right. Okay, this seems to be something unrelated to what I need. I might be stupid, but I don't think that most of the paper is even relevant. Yeah, okay, no, so that's the super sampling part. We don't need the super sampling part. We just want this part. And then AT will be different. So 5.2 and 6.2 is what they are linking to. So subpixel buffers, and then limiting the amount of blur. Okay, so that and 6.2, which is limiting the residual. Sorry, I'm not native. Similar to approach for limiting spatial blur, we would like to set a lower bound so that the residual in the next frame remains within a threshold. Okay, so that's ultimately what we care about. That's cool. So let's look at 5.2 first, because that seems to be the main thing. Comparison of signal drift for simple round-robin subpixel update sequence and our irregular sequence. Okay. Respective blur threshold. That's okay. That doesn't really tell me much. That's cool, I guess. That's about like jittering. So what is this? That's ultimately what we need. I'm gonna just get rid of the browser window. Yeah, right now this is like our metric for new samples. So maybe we can tone it down even more. Don't want to like waste any computation power, but I think that 0.1 is probably a good idea. Seems good enough to me. And what else could we be using? There's the previous screen. Could use normal. It would be possible, certainly, but it would miss a lot of the teeny tiny details that are quite necessary. But ultimately we should probably be doing that. Yeah, no, we should do that. So let's make a boolean. Is new fragment, is new. Yeah, is new fragment. And then we'll say this, and so we'll have the ambient there. Right, and we'll just hold on. Okay, so we need 1 divided by and then 1 plus the temporal. Right? Or no, just 1 divided by the temporal. That way, then, yeah. When we make this 1, this will be 1, so it will just go to the non-accumulated, whatever you want to call it. And then, yeah, we do this. And if, like, either that or it is new fragment, we should just make it is new fragment, and we'll pull this into the is new fragment. That is probably a better idea. So got that. Why did I do that? Oh, okay, no, I get it. We could write that in simpler terms. Okay. That's that. Is that even needed then? Temporal. So this is using temporal. And this is also 15. So, I mean, first it's 0, right? Then, we have that going on. We're adding 1 to it. But we're also adding 1 here. That's not... Let's try and see if this already, like, accumulates it. It does not. Okay, cool. That kind of makes sense. Why though? Because I want at least that to be right. 1 divided by temp A would be the mixing factor. That is correct. Maybe this is always true, which I honestly doubt. But you never know, so hey. Let's see. I think this is right. No, okay. That is fine. Saturate is not equal to that. Yep, that would be just out of screen, out of bounds. We don't do this. Also, where's my game time actually changing? I don't even want that. Game rule. Game rule, do daylight cycle. False. Oh, that, by the way, that you just saw was like an issue with the volumetrics. Currently, the densities change. Like, I changed the density based on the time of day. And it explodes at a certain time, which is very not good, but hey. Anyway. Yeah, let's make it daytime, because otherwise we can't see literally anything. Yeah. So anyway, that was correct. And this, I believe, was also correct. Okay, no. I mean, what did I have here before? Let's just go back for a second. I'm gonna keep this here. I'm gonna copy that and then go back to what I had before. Right? Because, what did I change here that was so out of pocket? Nothing, right? So essentially what I should just like make this one. Let's do that. Let's act like we don't need the weight. Let's just dismiss it. Okay, so this works. That's great. But now we do not have proper temporal accumulation. We just have like the bare minimum, essentially. So yeah, we want to not have the bare minimum, obviously. And it does the very basics. So what we're gonna actually do is we're gonna bring back in our is new fragment boolean, and we're gonna do this. And this does not work. That is why. That is actually because I just commented out my weight, which is not what I was supposed to do. Okay, so let's see the stability of this. So this is decent, right? This kind of gets somewhere. Essentially, right now what it's doing is it's just like a binary sort of filter. Right, so it does not do a very great job at like minor inconveniences. It's only like, it only actually like change, like, how do I say this? It only does a good job when the surface is actually changing after reprojection, like disocclusions, right? But when it's just getting reprojected slightly off, in a slightly off manner, it's just one. So that's why things become very blurry, right? If I like move around, then you get like, you lose a lot of definition in the global illumination here, because it's binary, right? It's just true or false at the moment. And you do get some trails there in the background, right? But that is mainly because of I mean, probably just depth inaccuracies and like whatchamacallit, precision issues. So anyhow, let's see. So we have the new fragment, and now we want to actually use our weight to drive the entire rest of this thing. So let's see here. Presence of scene motion. Oh, wait. First get out of here. To not make my PC die. And then here. Okay, so as discussed later on, the presence of scene motion requires us to limit this indefinite accumulation of uniformly weighted samples, even for pixels that remain visible for over many frames. That's what I just described before. To do so, they prescribe lower bounds on the value of 80 that override 6. Okay, so essentially, yeah, right, that's our mixing factor, and what we're changing is this at the moment. Hi, Sixthridge. Welcome. It has been so long since I last streamed anything. I'm glad you're here. We haven't talked in ages as well. Yeah. How you doing? How's life? How's shaders and uni and stuff? It's not that complicated. It's really just a temporal filter. It's what they or not they, but Yang, Nihab, Sander, and some other people recommend you do for TAA, actually, because this is, I mean, it's really just a TAA paper, but the SVGF paper linked this for what you also should be using for temporal accumulation of GI. So I'm just looking into this, kind of refining my temporal filter. Not really doing shadery things at the moment, that's fine. I've taken multiple breaks in between as well, since it's not my job, right? I have to dip out. Making dinner, ooh. Well, I wish you a great dinner time. Hope it all goes well. I'ma just be here. I'm not doing much. I'm just working on my temporal filter and just answering some questions if people have any about Prism and stuff, but that's essentially the gist of it. So, ooh, notification. Anyway, yeah, that's what I'm doing. Trying to figure this stuff out. Yeah. Projection map. Never heard it called that, being called that. Okay. Okay, so this is like the new update rule for the effective number of samples, I believe. Hey, Spack Eagle. How you doing? We have the whole squad up in here now. That's crazy. But yeah. Okay, so oh, okay, wait. So I'm kind of confused what this means. Okay, doing alright. I'm glad to hear. Okay, so why am I doing this that way? Shouldn't that be the other way around? Oh, there we got our issues again. There we go. Shouldn't I be doing this the other way around? This seems wrong to me. Maybe it's probably something because of my weight that I've used before. But yes, let's see. Okay, now this doesn't work for some reason. 1 divided by that. Seems right to me. And this goes up. Oh wait, no, I think I know. Hold up. Oh, we just need to switch these. Yes, indeed. We just need to switch these. I'm just working on my temporal filter, by the way. Nothing fancy. I'm also just like here to answer questions about Prism if anybody has any. Because I've seen some people have some. And so I was just like, sure. I'm always like responding on Discord as well, obviously, but this is one other place that I can actually talk to people to. Talk to people at, rather. Or from. But yeah. Prism is going pretty well, I would say. It's just that I don't have like any special denoising stuff yet. And I'm really missing like auto exposure in this. Because like going into rooms like these and going outside would look so much better with like proper auto exposure, but it is what it is. I will add it soon, hopefully. That's definitely something I do need to add before going into like a testing phase. Because well, the night is just very dark, right? So emissives are way too bright at night, which is a whole different kind of issue, but actually let me just that's a lot of fireflies. It's not even fireflies in the sense that it like sparse, it's just way too bright. Be gone. Fuck, I can't see anything. Maybe this would help. There we go. Now there you can kind of see like the precision of my voxelizer. But it, you know, it doesn't destroy everything, at least. But yeah, so I think we might use the same edit theme. It's not, actually, it's not cat chin. I never knew how to fucking call it or pronounce it, but no. I think you mentioned it like on the last stream like 2 years ago as well. But no, I use Tokyo Night, that's what it's called, and SF Mono is my font. So yeah, we do not use the same editor actually. And I'ma just go back to like noontime because and watch it explode in your eyes. Amazing. Oh, hold on. I'll be right back. I need to like text somebody. But yeah, no, I'm not using not using cat chin. I'm always just thinking of cappuccino when I read that. So yeah, It was you, but you two guys in the last one as well. Maybe everybody else is just not alive at these times of day. It's not like the most normal time to watch a live stream for Americans, so it kind of makes sense, I guess. But yeah. So anyway, now that we got that part, and I will just make this 0 and have that be 0 as well, because then we can get rid of this, and then have that be 1. Because then we can actually do this the way that like the notation in the paper suggests. So this would be alpha t, I think. Ugh, I have to switch all the time. Maybe I might just consider to just... Whoops. I might consider to just stream my entire screen at some point. Because that's kind of annoying having to switch all the time. Anyway. Right, so that's alpha t. That's what it would be then. And I'm gonna just go ahead and size that down as well. Just, I mean, you can barely read it probably, but I'm just, yeah, just gonna do it like that. So, what am I doing? Alpha t. This is alpha t. And then nt. So n temp.a is nt essentially. So we're doing this and then float nt, which is temp.a, right? What would be like the right? Oh, okay, no, so this is after the... I get it. So nt would then just be this. Which we should probably switch it around, but I'm not sure what implications that has for the rest of the paper, so I'm gonna just plot that in there and plot this in here. And this should be just the same thing as what we had before, just makes more sense in the context of like the paper. We'll just resize that a little bit. Yeah, so that looks good to me. Browser window. This is way too small. Can't see anything. So this is like our like weight for the current accumulation, I believe. And so I see. Okay. I think actually this is kind of like something that I that I derived once. It was for something completely different, but I mean, it's not quite different. It was for variance estimation, but let's see, because this would be a funny coincidence. Shader lab. What did I call it? Research. I don't think it was research. Maybe rants, other notes, logs. It's gotta be somewhere. Revisiting real-time SSS. I know I still have like screenshots somewhere. It doesn't really matter, let's be honest, but anyway, okay, no, I'm not gonna search for that, but it looks oddly similar to something that I derived once, so like, interesting, okay. But this should be just the same thing as this. This should just be the same thing as this when alpha t is this. So I will try this. So NT, that's a pretty big expression. I'm not sure how to feel about it. But this is just a reciprocal. So RCP. And then... Huh. Alright. So this would be power 2 of alpha t plus... I need to switch windows the entire time, that's why it's kind of a pain for me here. Alpha t, and that to the power of 2 as well. And then that divided by the temp A, which is getting sampled at the previous position, which I think is what they mean by the pi of t minus 1, because here they call this the projection map, which is a weird thing to call it, but sure, I will allow it. But yeah, so let's see if we make it that, if it's still stable, or if it blows up into oblivion. It does blow up into oblivion. Amazing. Okay. That is probably because this is 0 at some point. So... I think I know how to fix this. Let's, I mean, let's see. This would need to be at least 1. And they do say to initialize it to 1 here. But then they also add 1 here, which would mean that on the first frame it would only have half the contribution, which, you know, wait, okay, no, wait, they initialize this to 1. Okay, that makes more sense. So it's not temp A that gets initialized to 1, it's actually alpha t and nt that gets initialized to 1. So we need to create these beforehand. And, actually we could just make this like, just negate the, condition here to have the code be cleaner. So we'll just do it like that. So let's see here again. I think this should be better, at least. Nope, it's still dark. Because it's NT, right? Huh. Okay. So that would be that. I'm probably missing something here. So, I mean, yeah, no, this should be temp.a, and this should also be temp.a. I'm pretty sure. And temp.a needs to be at least 1. Like, it can't be anything else than 1. Like, let's see here, right? if alpha t is 0, then it's just going to be the same as that, which is weird. This is confusing me for some reason. It shouldn't. I need to reread the parts of the paper. So at this occlusion, they initialize both of them to 1, and then after that they update them. Okay. I think I know there's one part that I'm missing, surely. I think I know why or what now, but let's see here. I think we should probably check if it's like the newest screen, which I'm not sure how to do that. One knows when a shader dev is in the flow when they talk to themselves and are saying out loud what they are doing. I mean, to be entirely honest with you, I do that a lot, even when I'm not streaming, right? I'd just be there like explaining it to myself essentially. It helps for me, at least. Now I'm not sure what the how I would do that, like check if it's the first frame. I think I could just, if I move this up here, I could just check if the alpha channel is 0, I believe, because otherwise it won't be. So no, not 1, 0. So if it's a new fragment, let's try this again, shall we? You also do that? That's why that's why you said that. I think it's universal kind of experience. Probably. I'm guessing. We store the variance reduction factor for each pixel and use this value to set the per pixel smoothing factor. Oh, so they're first doing this one. That would make sense. I don't think this changes anything, let's be honest. Or it does, actually. Why did that change anything? Alpha T. Oh, no, okay, I see it now. Yeah, no, I see it now. And this would be temp A otherwise? Is that right? I'm getting confused here. Maybe not. I mean... yeah, no. Like, if we just ignore the is new fragment part here, then... I mean, I just really need to know what, like, NT minus 1 is. Would be the, like... this should be pretty easy to figure out. But for some reason... So... I mean... it really shouldn't be that deep. This just needs to be... like, temp A needs to be 0 on the first... thing. I mean, if I replace this again, then this should be... Okay, now this works. Right? Alpha T, we can, yeah, we can just do that. Okay, that's cool. There. We do this. Is new fragment. Oh yeah, no, we need to do this if it's a new fragment, obviously. I'm probably stupid. Okay, now we get it. There we go. We figured it out, guys. That totally didn't take ages. But I did it. We don't even have like a weight factor in here. But at least it's according to the paper's notation now. Amazing. Okay, so anyway, back to the math. Oh no. So 5.2 and 6.2 is what they link to for the thresholds. Given a threshold, the velocity, we would like to compute the small smoothing factor that provides the greatest degree of anti-aliasing. I mean, they talk about anti-aliasing, it's just, you know, it applies to, apparently applies to GI as well. Like in the case of traditional Benelian ray projection, which admits a bound on A by inverting 11 or more, complex algorithm does not lend itself on a similar analysis. Phoenix provides a more detailed... okay. Well, I love how the wall looks lit by the bounce light from the ground. I mean, yeah, I think this is like one of my favorite just things to look at. It's so simple, but Prism has like a very neutral tone map, so it looks very yeah, real. And not so overly contrasty and saturated and whatnot. The tone map is actually quite interesting, because I just like engineered it like a few days ago, and it does like some pretty cool stuff that I don't think any other tone map does. But yeah, we combine two strategies to address this problem. That is about the jittering. I don't care about that. Rather than bound the variance of the sample distribution. No, that's the sample distribution. I don't want that either. We compute numerically in an offline simulation. Specifically, we compute the moments of the sample distribution. So the saturation preserving term. Yeah, that was like the start of it. Yeah. I've extended it to like preserve hues, and it also like has hue shifts now, like not hue shifts from the tone scale, but hue shifts because you want them, right? Like when colors get really bright. Like, I mean, it's the one that I'm using right now, and I can just disable the hue shifting if I want to, so I can just show it off right now. So let's say we go into this thing here. I mean, you can kind of tell that there's some hue shifting here, right? Like in the red of the redstone, but it's not very apparent. So if I pull up the whatchamacallit, exposure, then you can see it better, right? It's essentially yellow here. So that's that. And I can just disable it in the tone map. So if I go into tone maps, you can't see this in the code right now, but it's really cryptic and not that interesting to look at. So we just don't do the hue shifting, then this was what you get. So you can just put it on or off, essentially. Which I'm probably just gonna turn it into like a control from like 0 to 1 or something. But yeah, you can put it on and off. You can also disable the desaturation, right? So these bright colors have the same saturation as they had before the tone map was applied. But yeah, it's kind of necessary to actually express the high dynamic range well. And then there's one thing that I'm doing, which is I'm also preserving the luminance. I'm also preserving the luminance, not of the original image, but if you were to apply the tone scale, you get a certain brightness back. And so I'm like preserving the saturation and preserving the hue, and that kind of changes the like perceived brightness of the colors a bit. So I have like one additional thing that also preserves the luminance, despite already accounting for saturation and all that stuff. And then in a final step, when I'm accounting for that change in luminance, some colors go out of like gamut, which is like the colors that you can like display, right? Because say like you have a color that got really saturated and lost a lot of like brightness from that, then I am accounting for that brightness, and then suddenly one of the channels is above 1, and then I'm desaturating that color until like the highest color channel is back at 1. And so if I disable doing that, right, if I disable that desaturation to gamma, you can see, you know, back there, that's just like the grass looks radioactive, and the sky back there just looks kind of pastel and too blue. And if you enable that desaturation to gamut again, it doesn't, essentially, right? Otherwise the colors would actually never reach 1, and that way they do. So there's some fun stuff that I'm doing here. And currently this is using the hue shifts from ACES. I could also be using the ones from the LMS color space, in which case colors get really saturated, which I didn't really like. And ACES leaves them a lot more neutral. You know, this is like, with LMS, eventually yellow just turns green, which really was not something that I was looking for specifically, right? I mean, you have to push it quite far, admittedly, right? And this only works because I'm like having hue preservation in here. But otherwise, this would eventually turn green, and just generally doesn't look that great. So, yeah, anyway. So that's my tone map. And let's go back to ACES, because I do not want funky colors. But yeah. Tone map. I mean, I can show like the before and after. Have you tried the Lab color space? I've heard of it. I'm not sure what it's used for commonly. Is it like a perception based tone map? Because I mean, there's ACES, but ACES tries to model cameras, and with this tone map I'm trying to model the human eye rather than a camera. So I'm not sure if Lab would be a great choice. LMS I know is for cone sensitivity. That's why I have it as an option, but ACES just turned out to have better hue shifts. That's why I'm using it. But yeah. So yeah, I can just go into final and show the before and after of the tone map. Right? Oh wait. Yeah, I have like some saturation correction still, because Aces kind of desaturates them, so I have like a slight correction factor for that. But yeah, so this is like the before and after of the tone map. Which, you know, is yeah, it really only changes things where it needs to. It doesn't touch any other parts of the image. So that's pretty neat, I would say. And yeah, it's perceptual, exactly. Because ideally what you would display is just plain sRGB plus some hue shift, but you just can't do that because of the brightness, right? And your screen saying nuh-uh. But this way you get very close. You get very, very close. What was I gonna say? Yeah, LMS, if you change to LMS, it just... I mean, I would also have to disable the color grading. Yeah, so this would be LMS, which I just don't like the way that it you know, compresses colors. They look, I mean, here you can mostly see it in the sky, but I don't know. Something about the LMS color space doesn't appeal to me. Oh, I'm using Aces hue shifts. But you can use any, like, chromatic adaptation matrix for this, and it will work just fine. I've designed, like, this tone map in, like, a... like, kind of like the... like a specular model, where you can just plot in the tone scale, and plot in the amount of contrast you want, and plot in the amount of hue shifts you want, and you can, like, kind of build your own kind of thing, right? Anyway. Oh... So that's my tone map. And yeah, what I meant with like luminance, like that it preserves luminance, is that if I were to use the tone scale that I just use right now for this tone map, so just add tone scale at the end there, then you can see what the resaturation does, kind of. I'm not sure how well it shows. I'm not sure how well it shows, but back there, you can see the resaturation doing its job at the horizon. Which you might like this, and you might not, but that's why I have a toggle for it. But it's the same brightness as if you were to just apply the tone scale. So, yeah. Tone maps. Pretty cool stuff. The right side would be more like something that looks like continuum, I guess. But yeah. And so you can kind of like also see like some difference here indoors, especially with very bright light sources. You can see that the tone map does a better job at representing like brighter parts, right? Kind of shifts them more nicely. Especially like, you know, when it's very bright, you can really see the difference, right? Otherwise it just kind of looks like it's clipping, although it really isn't, but it you know, it just looks better. So anyway, I will stop the shenanigans and go back to work. Because I do want to get somewhere with my temporal accumulation. I don't want to finish it necessarily, but would be cool to get at least something, some parts working. But yeah, that's my tone map. My current tone map, I should say, because it's probably gonna continue to develop with settings and whatnot. Because I don't have like contrast and white balance settings yet. But it's on the way. So yeah, temporal filtering. Very cool. I'm just gonna scale this down again. And splurt the paper back on screen here. Okay. We average the moments. Okay, so they are using velocity, it seems. Okay, wait, so we're taking the max. What is K? I want to know what K is. It's mentioned here, it seems. KBK would be contributed to all of the... Okay, so that's subpixel buffers. That's something about jittering. I don't want that. Apply the following update. Okay, sure. Maybe this is not the section that we need. Maybe this. Upgrades for limiting the degree of spatial blur. We would like to set a low bound on that such. Yeah, changes in the shading is essentially what we want. Following the derivation is to replace it with... Add the pixels where the shading is constant. Oh wait, no, that's different, okay. A strategy to adapt the temporal changes is to replace 21, which is what? 21 is this. Oh, okay, so don't even max that where this is. Okay. Okay. They're not specifying any anything really. So that's interesting. But okay, so essentially they're just modifying this to be higher, which I guess makes sense. Let's see. Because if this is high, then it's just gonna be the previous one, right? Okay. So we want 1 minus the weight to be the multiply of this. So this would be, let's see, weight plus 1 minus the weight, and then that, I think, right? Feels approximately right. Maybe it's the exact opposite of what I was thinking, which I wouldn't be surprised. This kind of seems like it. Now I can't say that I have mathematical proof that this is right, but it does look very converging. That's something you can say, I don't know. This looks very good. In terms of how fast it accumulates, at least. I feel like this is more stable than what we had before. So what would this be? Can I simplify this somehow? I'm not sure. But this does look right. So if I were to actually up the resolution now, which will take a massive toll on my FPS, but that's fine. Then we get a cool image. I approve of this. And it does accumulate, hey! Yeah, now like about that, right? Like the change in scenery thing. I'm gonna have to figure that out still. But that seems like a painful thing to have to worry about. So I'm gonna probably do that. I don't know when, sometime. But yeah, this looks like it is accumulating. Because before, right, in like those, like especially on edges, you could see it very well that it kind of had issues to accumulate properly. But this looks just right. Nope, I don't want to go into my tone map. So ultimately, I would pull this into a separate file. I still have like bad temporal accumulation from like my first attempt at GI, which I think was actually back when I used screen space. But now I'm just better now. I figured it out. I'm path tracing guy now. Well, I'm a voxel path tracing guy now. I'm one of the cool kids. At least I aspire to be. I don't know. So anyway, yeah. I think that looks pretty good. I'm gonna just pull that into an include. And I will also, because I can, raise the exposure a little bit, because it just looks better. Especially here indoors. Just looks better. Yep. Seems pretty stable to me. I mean, we can like worry about like the weight later, like the actual weight. That's whatever, I guess. I was hoping to find something about that in the paper, but it doesn't seem to actually suggest any weights specifically. So I will just, let's see, I still have the temporal filter GLSL here. So that was my old depth weight, which I think was based on the SVGF paper. And I'm gonna just, I don't know, maybe I'm gonna use this, I don't know. Not sure yet. Linearized depth. I mean, hypothetically, I could be using the same weights, but tell you normal. Okay, so I think I'm honestly just gonna rewrite this. This is utter weirdness. What's the AO? It looks really nice. I mean, it's just there from the GI, naturally. I'm not doing anything special for it. If you path trace accurately, you just get... I mean, it's essentially what RTAO is, just with added color on top. That's what GI is. No, it's yeah. If I was to give you an actual answer to this, then RTAO. But it's really just path traced global illumination. Yeah. It comes included in the package, if you will. So that's pretty neat. Yeah. So I'm gonna just move. Or actually, I'm just gonna keep the weights. I'm not gonna keep the temporal filter. I'm gonna keep those. Just gonna comment them out, try them later, and then I will be going into here and actually include this stuff. I don't know why there was a space there. Yeah, let's not do that. What's that in actually? Temporal filter, lib fragment denoising. Fragment denoising. Temporal filter. And then, well, let's see here. What would make sense to include? I mean, do we want to? I don't know. Yeah, just the temporal buffer and then the previous depth and previous normal and also the normal. The normal. Weird to say that. Anyway, and then yeah, ambient should just be an in-out, I guess. And NT2 and alpha T2. So, in conclusion, we need an in-out alpha T. We need an in-out. Oh, this is a float. NT. We need an in-out Vec3 ambient. And then a bunch of ins. So near and far would be good to include. So I'm gonna like organize this in like a more neat manner later. But yeah, so previous depth would be pretty necessary. Or I'm just gonna call this CO previous and CO and normal previous flotta. That's not what I wanted to write there. And float normal. Right, what else? This should just be a setting, so I will make a setting on float GI temporal temporal weight sensitivity. Sensitivity. Okay. Got that. And yeah. So we'll have a float get temporal weight. We're gonna have a float get a temporal depth weight. We're gonna have a get temporal normal weight. We're gonna have just get temporal weight. And then we're gonna have a is new fragment, which is not a float, but a boolean. Okay, so what do we need for this? We need the previous depth, we need the current depth, and that is pretty much it. Scaled. Okay. So maybe we can do this later. Let's just implement it in a way that doesn't account for weights first. So let's get rid of this and this and this and this, because we don't need all of that when we don't account for weights. We only need all this, right? We check back. I mean, well, let's see. Yeah, weight would be excluded from there. Temporal is there. Ambient, temp A. There's something I'm missing again. Hey. Previous screen. What is the debug thing saying? Oh, I mean, yeah. Duh. Okay. At least I'm not completely out of my mind. That's good. So what would that look like? We would have a temporal filter call, and then we would have all of these, well, all of these things here. Actually, working on my own little Minecrafty voxel engine. Ooh, I've always wanted to do voxel engine. I think we talked about this before even. Or maybe not. I think Jesse had wanted to do something similar. But yeah. Yeah, I saw like on YouTube sometimes like videos of like voxel engines with like millions of voxels. It's pretty great. Especially when they include physics, so you get something like teardown. I love that. Yeah, like an open world, like sandbox voxel game, but like with so much voxel detail would be so cool. Because destruction is like very satisfying with voxels in my opinion. It's just an entire vibe. That would be pretty great. Actually, I'm just gonna... No, this is fine, actually. This is fine. Alpha T does not really need to get updated. So that can just be an in. And I should really rename this stuff to something more descriptive. It's really fun. How far along the line are you? Like, are you working on like the first cube, or is it like already some sort of generation in there with culling and whatnot. Because I've started doing like a voxel game. I didn't do an engine yet. I was doing it in Unity when I started coding. I got to like terrain generation, but then culling completely screwed me over back then. And I didn't really know what to do, but I'm considering to try that again. Working on the light mapping at the moment. Oh, so we're quite far into the whole thing already. Damn, light mapping. Are you gonna like use like a similar approach to Minecraft there? So I'm not a huge fan of it, I'll be honest. But it works, so I'm not complaining. So anyhow, ambient. Right, we obviously do need our temporal data. So temporal data. That's just what I'm going to call it, so it's going to be temporal data. And this is going to go away. So is new fragment. We're going to do this one first. Weight, and weight is just going to be if it was lower than what now? I already forgot. I think I was using 0.1. Whoops, that was too much. Yep, I was using 0.1. Previous screen. Vec4 temporal data. So just keep it oh yeah, we need that too then in the even if we if we get rid of all of this, then I think it should just be black in the game. No, it's giving an error. Oh right, I mean yeah, because we're stupid me. Okay. So let's try to actually do this. We don't need it linear. But anyway. Okay, so we do have ambient defined. Yes, it's the same approach, but with RGB block light. Well, at least that. At least that. Temp RGB ambient. Oh right, if we whoops, that I didn't want to do. I didn't want to get into the git lens inspect part. This should just be the path tracer output. Just gonna look horrible on stream. I apologize in advance. So anyhow. 15 right, ambient. So we need the temporal filter to do some stuff. With ambient, with the temporal buffer, which is I mean temporal data, that's what we're gonna call it. So oop. And then what do we need? I mean alpha t we don't really need at all outside of the function. We put n previous into there, which would it's just part of temporal data. What am I saying? We do need to have a float nt, which could be anything, so I'm just gonna make it 0 for now, and so we're gonna have NT. What else is there? If we want to decide if it's new fragment, we do need the previous screen, and that's I think that's it. So what would that be in terms of parameters? Sorry, I'm taking like ages for this, but I do want to like do this correctly. So this would be vec3 current data. That's what I'm gonna call it. Current data and vec4 temporal data. We're gonna have an out float nt. You don't need to know what value it is, because that's in temporal data. Or maybe we want to split temporal data up, in which case, you know, we could do that. So we could make it that, and then n the previous. Wow, this is messy. Jesus Christ. No, let's not. Let's not do that. So out nt, and then also in. Previous screen. Which is a vec2 previous chord, I'm gonna call it. Or chord previous. I don't know. Something along those lines. So I'm do that. And so then first we're gonna have the boolean is new fragment. With our weight being 1. And then core prev or prev, whatever. And temporal data. And I think actually this alone should just be the path tracer output again. No, okay, we got an error somewhere. Scroll. Incompatible type for parameter core previous. What is this then? Isn't it vec2? Oh, I made it vec3. That is my bad. Okay, yeah, so this is just the path tracer output. Which is fine by me. So say, okay, we're just gonna copy this because I feel like that's gonna be easier. Whoops, nope. Alpha T temporal data.a, that too. Is this not being used? Oh, because this is already okay. I mean, this is all actually NT previous. So this is NT previous, and this is NT previous. We're not gonna do that. Or actually, we need to do that, right? Yeah, we can, I don't care. And so it would be current data and temporal data based on alpha t. That seems good to me. Let's see if it translates over. It doesn't. Awesome. Oh, to be a shader dev. Undefined variable temp. Temp. Oh. My bad. Still not? Dang. W. That should be fine. Alpha T. Oh, we don't have W defined. Okay, that makes sense. Just make it 1 for now, because that's the most simple assumption of all. Okay, this doesn't want to work. I don't know. Undefined variable alpha T. Oh, there was something else there. Undefined function has no return statement. What do you mean function has no return statement? You're right, it does not have a return statement. What else? Undefined variable alpha T. Oh, right. Yeah. Load alpha T. Okay, we're getting somewhere. It's not correct by any means, but it's something. So NT. Okay, I can just put this above because we need the weight before we get the fragment. So that's just gonna be there. Okay, I have no idea why this doesn't... I don't know. What if... Did I break it? Oh. Well... Isn't that the same thing though? Question mark? I don't think it is. Yeah, no. The weight is not the issue. I doubt that this is. So what the hell is wrong here? NT equals 0. That's what we initialize it to. NT... Oh, that's right. Obviously need to update that regardless. And now it's gone. Oh, maybe... Or, I don't know. Wait. So NT? Otherwise, NT... Previous... Yeah, it seems right to me, though. That's the thing. Whoops, I didn't want to do that. Temporal. Does this need to be an in-out? I don't think why it does. Yeah, it doesn't change anything. I was like this close to saying, what the hell? Maybe because we didn't initialize it. Nope. Maybe because we need to do that. Nope. Well, well, well. Hmm. Can try to just replace this stuff again. Because I had it figured out before. Why all this nonsense? So temporal data, temporal data, temporal data. And T is also temporal data. And T is this. Oh wow, okay, so I am tripping. What is different about this? Is that... Oh. I mean, I guess. I think that's it. Nope. That's breaking again. The hell? So alpha T. What's the thing saying? What's the paper saying? I don't want to do any guessing games. Okay. Alpha T should be... Okay. Interesting. Very interesting. Define variable temp. Oh yeah, because it's temporal data. Oh. So if I were to make an NT previous and not delete the others, I'll just replace it one by one to see if, you know, stuff makes sense. Okay. Why is this so smeary once of us? What? If I do that, it's not? Excuse me? Oh wait, no it is. Okay, wait. Okay, no. Never mind. forgot I didn't have any weighting factors yet. But still, this is still worse. This is like even worse than this. Right? I'm not crazy, right? I might be. I don't know. Wait, if I do this? Go away. I don't like tool tips. Go away. Actually just stays there, okay. Well, there's something that I overlooked here. Surely. If I pull this out to here. Okay, this does work. This is what it tells me to do, right? So in previous, it should really be this. Okay, we're getting somewhere. We're getting somewhere. This is closer to what it actually should be, so that's cool. I can just I don't know, not do this at all, and otherwise have that just be chilling around there. Yeah. Cool. I think we should do this the other way around. So or actually in terms of computation, I think this might actually be better. Yeah. I'm just doing this instead. Cool. So we got that working for us. Is it a problem if I do this before we rest? Seems like it is. Okay. Even though I do wonder why. Well, anyway, let's see if this all checks out with our weight as well. So I will be getting these. What do we need for the depth weight? Let's do this one first. So we need previously 0, AC 0. We need screen or what is it, text chord? I think it is, right? Yeah. So I'll put that there. Pull this up. Like so, that makes more sense for me personally. And do we want to linearize? Maybe. Let's see. Linear. There we go. So let's do this. Temporal NT, previous chord. And then in float Z0, in float previous. In float Z far, in float Z near. And with that, it should be good. We should at least have it running still, which we do not. Once again, I ask you why. Undefined variable. As far as you near. Wait, what? Undefined variable. Then the deferred. Oh yeah. Here it needs to be far and near, and would that be? Do I have that anywhere? Rev depth. Okay, let's see. Still not quite. Float select 2. Wait, why would that ever be? Oh. Float select 2. Implicit cast. I mean, did I mistype something here? Wait, text chord. Oh, wait, okay. Press screen. Press screen is a vec2, so this should be fine. Okay, it is. I don't know what I did before. That's weird. So anyway, we got that. So now we need to move on and do the depth weight, which let's first copy the actual line in here. We can see what it actually needs. So this needs the float of Z0 previous, of just Z0, the chord and the previous chord in it. So we're just gonna replace those quickly. Previous depth and depth, coordinate, and previous coordinate, and these are the derivatives of the depth. But which one though? Seems like I used the linear depth there. Even though I don't think that's really what I should be doing. But I guess, I mean, let's see, what does the SVGF paper actually say? So I'm not 100%. I don't think I'd be on the money if I was assuming anything here. So let's see. What does this say about depth again? Here. We estimate the local depth not using screen space. Partial derivatives of clip space depth. So clip space is not world space. Makes sense actually, because otherwise you're gonna get way too strong of a influence in the back. And now I have the SVGF paper open twice. Amazing. That's cool and all, but no. Okay. Kill. So what we want is for this to just be dxdy or dxdy vec2 of, then we can just basically take this right as it's written there. There we go. This looks a lot more easy to read. Clip space, okay. So it's all clip space. None of this is ever not clip space, it seems. Is this actually right? I don't see how this how sigma z actually increases the intensity, but I'll experiment with it. It's probably fine. Let's see here, get temporal depth weight. I have something pretty similar here. It's not quite the same, but close enough. Get temporal depth weight. So we can make that one of them. I think this shouldn't have any issues. Nope. Okay. So we can define float get temporal weight. And then we'll just take all the parameters, because then later we can just multiply them together. Do previous chord. We'll just use it as a wrapper for now. Get temporal weight. Be this. Chord prev. Yeah, have to be more consistent with my naming schemes, I'm noticing right now. Otherwise this whole thing won't make any sense. Okay, so and the second I try it out, obviously it doesn't work. Undefined variable sigma z. That is right. Okay, cool. So that's something. What is the performance like? Well, it really depends on what scene you're in. Right now here I'm getting 120 FPS, but I also have like a decent-ish setup. Gotta head out. Alright. I'm glad you came by. But yeah, the performance really depends on like where you're standing. And what effects you got enabled and so on. But I can say that it is definitely a high-end shader pack, not a mid-range or whatever. It's kind of like Kappa and Continuum and those more high-end Apollo RT, if you know that one. It kind of, yeah, goes into that direction in terms of performance. Alright, so this is very sensitive for some reason. What was P and Q again in the SVGF paper? I have no idea, I'll be honest. P and Q. This variance estimation, that's not what we want. A normal point P. So Q is the... Oh. I mean, I can try to switch those around. I don't think it'll make any difference really, but... I can try. Yeah, no. It's just the same thing. So yeah, I'm not sure why this is so sensitive now. Previous depth. Oh, these were all like linear. Even these here. Or maybe I need to switch this around. I am not sure. I don't think that's what it is. Or actually, hold on. No, it's not, right? Yeah, it's not. It is not what I thought it was. I don't think it is. Yeah, no. Okay. I mean, we can linearize it, sure. But that's not what the SVGF paper says, so I'm confused. If this goes away function defined as, and then it just says what I got written there. So, huh? That is weird. Maybe this one's too large. I mean, the paper does suggest a small value. Maybe it was that. far do I need to push this until that like actually does something? Jesus Christ. Oh wait, it does something. But just in the wrong places. Whoops. Do they even say what epsilon is? I don't think they do. Just gonna call it, oh yeah, that's a small value. Yeah. I mean, it's just for division by 0, that's what they're saying, so it is a really small value. Can you basically make this my internal epsilon? And the rest, I don't know. Why is this? I think this should be like lower if I want it to be stronger, right? Something's very fishy about this. Huh. Well, I quite frankly have no idea why this is working slash not working. B minus... I mean, the naive method would just be doing this but without the derivatives. And then dividing by the... No, sorry, multiplying by the sensitivity. Personally, that would make a lot of sense. I am so confusion. What is this? Like, if this is 0, it should just... Huh? Excuse me? I mean, this kind of works, but... I think it might be better to just like work with linear values, but... Oh man. Okay. So we're just gonna get near and far in here as well. So there we go. Near and far. Did I put them in the right order? Yes, I did. Let's switch those. I think as soon as I got the depth part finished, I'm probably gonna end the stream as well, because it's going to be dinner time soon here. And we do not want to miss out on dinner time. Z R. Right, so Lin, wait, no. Alright, Lin Z0 previous rise depth C0 previous here far. And then what I did is I took them of the linear things here. And I did this and this. So it's not clip space now, it is actually just straight up world space depth. Which that is not working. Why is that? Chord C0 previous. Got the weight here. Get rid of these programs, I don't need those. W depth. We have the normal depth. Now we have this line, which is ultimately all we need for the weight to be correctly accounted for. And it's not letting me. I don't like it. This is 1, right? This should just accumulate. Right, okay. Maybe I do want this to be 1. Who knows? Doesn't change anything, okay. Fair enough, I guess. Ow, that was my knee. I am unsure about this. Previous depth. I'm just gonna actually just copy this again and just compare. So, previous depth. That was linearized, okay. Times the 1z. Then this. Previous. Okay, that's alright. Now, what about the... Yep. Okay. That's the same. Yeah, I'm not sure. Low. W depth. Very, very weird. I mean, I basically just copied this. There's not really anything that I've changed. And I can just copy this in again and just like fill in the gaps, sort of thing. Previous depth. The depth. And this is that. This is that. And this is that. What the fuck? Wait, no. That's wrong too. What's happening now? That is wrong too. Right? Or is it actually correct and I'm just actually hallucinating now? Now it just looks like it's doing absolutely nothing. That's great. Lindsay previous. Oh, yeah, well, no shit. Okay. So yeah, it does seem to very much have an issue. Previous. There's gotta be something wrong with what I'm like actually putting in here. Ain't no way. NT chord previous 0 previous depth. Oh, I'm already linearizing this. I don't want that. So pick this out. What do you mean? What do you mean? Compilation error. What did I do? Unexpected token in. Oh yeah. Now I'm just making messy errors. Wow, okay. Would you look at that? So I'm not actually completely losing my mind. Amazing. Okay. And now we actually can try the SVGF version, which would just be this and then this and this and this. So that's what the SVGF. Yeah, right. Yeah, right. That looks amazing, doesn't it? Oh wow. How great looking. Yeah, no. Or maybe I'm just confusing what they mean by clip space depth, but this just works better. Anyway. The normal weight should be easy. It should be. I'm saying it should be because who knows? Maybe it's not going to be. But it should be. So let's just do that too. We get the normal weight. And this is the normal weight. So we got the normal. Crazy, right? And the previous normal. Or I'm just gonna go normal prev. And previous. This can be epsilon, I think, but maybe I did that for a reason, so we'll see. 1.28. depth weight. Or we can make that WZ and WN. And just add normal and normal previous. That's vec3s. Normal previous. Normal previous. And then, you know, we turn the multiply product of both. So yeah. I think that's what they do too in the SVGF paper. I can take a look and then check that out in a second. So they just use the dot product, and then I guess they're hoping that the exponent is like not like an equal number. Is that what you call them? Odd and equal numbers? I think so, right? But yeah, in their case, it is actually a equal number. I was just thinking about that because like we wouldn't need that saturate if this didn't get negative. Which, you know, sounds good to me. This probably has some weird behavior otherwise anyway. But I would say we first put in all the data here. So what is it? Normal, scaled, normal. Wait, no, not scaled normal, just normal map. And then why would I use the scaled normal map? Doesn't make any sense, right? Or actually, no, it does. Never mind, it does. It does. Scaled normal map, and then previous normal map. There. Just add that. Normal previous. And I think that should be good. Let's see. Something went wrong here. Things never work on a first try when I'm rushing it. When anybody rushes them. Which, yeah, normal. Are both of these vec4s? Yep, okay. XYZ and XYZ. Yep, okay, so that works. Great. Yeah, it looks neat. Things properly converge now, isn't that great? That's kind of important, I would say. Okay. We'll need all that. And this. And this. Just get what's necessary. And what's necessary is all in here. But yeah, so I'm guessing what would happen if we were to get rid of that small value here, it's probably gonna not work that great. Yeah, I was expecting. I'm not sure if epsilon would be enough for that. We'll see. It's not. Okay. That makes sense. That's why I added like a higher value there. I'm sure there's better ways to, you know, do this. But yeah, let's try to remove that saturate and instead make this dot product. Absolute. I don't think this necessarily changes much, it just kind of fixes some bugs that we may have had otherwise. Right. Okay, cool. Well, I guess this will be the time that I wrap up the stream. Yeah, we did, we made a whole goddamn temporal filter today. At least we refined it to a point where it's like actually very stable now, and it's like good, you know? Which, you know, that's quite nice to hear, I guess. Let's also put the resolution back down so it's actually like somewhat performant. Alright, wait. Maybe we're not quite done yet, perhaps. It seems that I added one parameter wrong, or something along those lines. Let's see, so... ZO? Oh yeah, right. Is there a scaled ZO? Scaled... There is! What a surprise. So anyway... When we, try this now, it should actually be like... good. Wait, hello? Hello? Did I change the wrong setting or something? Hello? Nope, not Hypixel. Oh, there we go. Okay. But yeah, so... a lot more stable now, huh? Looks great. Very cool. I mean, yeah, you still have like those little issues on the sides. Which, you know. It's just precision. Which is the issue. But the rest works very well now. I'm very pleased with this. Yeah. I mean, a good temporal filter is ultimately like one of the most important things for like a good denoising result. So I might tweak like the actual weights, but yeah, the actual filter now, pretty great. So here now we can stress test it. I'm just gonna hope that the stream is smooth with this. And it's not gonna like absolutely die of performance issues. But yeah, you can see it works fairly well. Like there's a lot of like normal detail here now, right? So there's a lot of stuff getting rejected by the temporal filter, which is, by the way it should be, right? It just looks very noisy because like 10 to 20% of the screen are pure noise, but those other like 80% is really like does make a big difference. Because you could think like, oh, we implemented a whole temporal filter that's gonna take us like some computation time, and yes it will, but you tend to focus more on the parts that are noisy rather than the ones that are not. And the ones that are not still make up quite a large part of the image. So overall, this is still very pleasing as a result. And I'm gonna just bump those up a little bit. But yeah. So that's that, right? Very cool. Yeah, we have water, which is pretty cool. I made some pretty cool water for this pack, which is it exists. It's there. Anyhow. Is this all path tracing, or are there shadow maps? Sorry, I didn't see it before. I don't know how long that message, like how long ago that message was. But so these shadows here are shadow map shadows, right? Like classic shadows. But there will be contact shadows, meaning that shadows like connect to the objects in a pixel perfect way, the same you would get with fully path traced ones. But all indirect shadows, like from ambient lighting, are fully path traced. Just these shadows that you see here right now, those are not. And you can see this little gap in between like the grass blades and the actual shadow there. This will be filled up with ray trace shadows. So it's nice and smooth. And it will essentially look like fully ray traced shadows. So I hope that answers your question. But yeah, that's what shadows will entail. Right. But yeah, that's how it's currently going. This is how stuff currently looks. I do like the way that the tone map is so neutral, so that I don't know, contrast just feels very, yeah, very realistic and neutral and whatnot. I feel like a lot of packs use cinematic tone maps because they like the contrast. But if you're doing like somewhat accurate path tracing, then you get that contrast naturally. Like here, this, like, I'm not adding any additional contrast to this image. This is all directly from the path tracer. And if I was to use any tone map that added additional contrast into the scene, then it would just completely ruin the look that I got going on, which I'm not keen about. So, but yeah, so This is how sunset looks. I do want to redo the atmosphere at some point. It's currently using Hilaire's model, Sebastian Hilaire. I'm not sure who knows the guy, but he's pretty cool. He does some pretty good papers. Mainly about atmospheric scattering as far as I'm aware. I mean, I'm sure he has like a bunch of papers, but this is probably what he's most known for. The modeling of the Earth's atmosphere. But yeah. I'm not even sure. I don't think that Purkinje shift actually does anything at the moment. Kind of looked like that for a second. I wouldn't mind it. It's just it surprised me. But yeah, midnight. If we go to like nighttime, then that's gonna be very dark. But if we up the exposure, it's not gonna be quite as dark. I mean, essentially, it looks almost black and white. It's not though. It's really not black and white at all. But it kind of looks like it, which understandable. But it's not. Just know that it's not. Because, I mean, now, like, we're gonna have, like, an explosion again, but as soon as we put down a light, you will see that it's actually not black and white. We would need to currently still pull down the block light intensity by quite a bit to make it enjoyable. But I'm hoping to fix this somehow. I'm not sure exactly how I will do that yet, because that's a problem for later me, but yeah, as you can see, we got a color in here. And yeah, most packs, they do Purkinje shift in like a naive way. And what they end up with is like most of the image doesn't have Purkinje shift, just the very dark parts. Whereas it should actually be most of the image has Purkinje shift, except for the very, you know, bright parts. And I mean, I can adjust it, right? If we pull this down, there will be less of a noticeable shift. But as soon as you get to like a certain point, it already doesn't look too, you know, it just kind of starts looking weird, even with like the most minimal amounts of change in the settings. So yeah, the settings that are physically correct are also the ones that I will probably be using. It doesn't like tint it in like a blue hue yet, which I'm actually not sure how realistic that is. Because most of the time, like, different sources say different things about the Purkinje shift. Some say that it's just the desaturation part. Some say that it's just desaturation, but the fact that it desaturates it in a certain way, right? Because certain colors get affected more by desaturation than others. Like red, for example, becomes darker than other colors, which is currently the case actually. So like if you take red wool, then you will see that it is pretty dark unless it's getting directly lit, but otherwise it's close to black, which is how it should be. But yeah, I'm not doing any tinting yet with a Purkinje shift. But yeah, nighttime. I don't have any stars yet. I do want to get to that eventually. I just didn't yet get to that. But yeah, overall, things are looking good. At least in terms of my analogy, I think it goes well. But yeah, you can see we do in fact have colors. It's quite strong, desaturation, but that's how it should be apparently. Because I'm using like physical units in all aspects of this shader pack, so if if Minecraft had a luminance meter or something to measure luminance, then you could actually go up to a block and measure how bright it is in physical units. Like the values that I'm working with in the shader pack are genuinely physical units. That's why I can also use the Purkinje shift in like a physically accurate way, because well, because the Purkinje shift is also a physical thing, like a physical phenomenon. Albeit perceptual, sure, but you know, it still uses physical units, and that looks really nice with the god rays. God damn. Good job, me, I guess. Anyway, I think this will be it for today. I'm not sure exactly when I'm gonna stream next time, but I hope it'll be sometime short in the near future. Today, I mean, we made a temporal filter, which is way more than I expected to get done, but anyway, yeah, I might do like a Q&A stream shortly before the release, or shortly or during the testing phase of Prism. I'm sure some of the testers will have some questions, and I'm sure that some of the community members will have some questions regarding the release, because it's not going to be too long. It's going in a good direction in general. It's just that cumulus clouds and TAA is missing, which is like two huge things, as well as, you know, GI denoising. And as soon as I got those things implemented, we can actually move on into like a fully early access state. I don't have any bloom yet, which is kind of sad, right? But all post-processing is secondary in terms of relevance and overall priority. So I'm gonna focus on getting the path tracing and like GI part of this done as good as possible. Full block intersections is only like the ones that... Okay. Full block intersections are the only ones that I currently support. That's what I wanted to say. And so I think it'll stay that way for a while. Because doing anything else other than that will massively reduce performance. And I want to worry about my denoiser first, because that will take up a lot of performance. So I want to get my denoiser decently performant first, right? And not have to wait until I can voxelize all blocks in this damn game until I can actually, you know, get started on voxelization. Because that... yeah, no. So anyway, yeah, I'm gonna call it here today. I am very glad that everybody came around. And for anyone that is still here, I do have a Patreon. So if you feel generous today, yeah, you can go there and leave me a few dollars so I can afford more coffee. And then, you know, cater to my caffeine addiction. So, yeah, I will see you next time, I guess. I'm not sure exactly when that will be, but I will let everybody know on Discord and the various platforms that I am on from time to time. All right. Bye-bye.